thank you, Matt, for a wonderful intro. And I don't know about you all, but I am very excited to see what uncensored stuff Matt will unleash on us. But with that, I have another exciting thing to do. I have roughly 25 minutes to cover about 60 slides of MySQL observability. So we'll get right into that and we'll move fast. Right, so jumping straight into what MySQL 8 observability has to offer is it offers those number of data sources where information for observability comes from. And I will go through all of them, explain what they are, what they provide, and how you can use them. The first one is show global status stuff. And this, to use Matt's terminology, is a granddaddy of all MySQL observability stuff. It uses a lot of status variables, most are counters, some are gauges, which really track various events inside of MySQL. Now, one thing you need to know about them is some of them are global and some of them are a session, right? Like, for example, in this case, we can see what questions as a global variable, status variable, which shows us a number of queries with service star handle since the star is pretty large. While if you look at the session, we see how many queries with given session run, which is obviously a lot smaller. And they are both can be helpful in different cases. One thing though is MySQL doesn't do a very good job at differentiating those. In some cases, you may query session status, as you can see, right, and see some huge numbers for things like Innodb rows deleted, inserted, and so on and so forth. Because while those variables are reported in a session status for some reason, these are only global variables which are not really maintained on per session basis, right? So, you know, wherever it is a bug or some, you know, awkward historical artifact, you have to be aware about that. One way we can use those session variable is to profile the query, right? So you can query the status, run the query, and then see how the variables have incremented. So in this case, we are doing a count star, which does a full table scan to compute number of rows it has, and we can see handler read next variable has incremented, right? Actually, full index scan, not full table scan, but same thing. Now, in many cases, when we are looking at those status variables, we're not really interested in a value since the start. Right, what we're interested in the change with the delta for second or some other interval, and you can get that data using MySQL admin tool, right, like I'm using in this case, or if you're using Percona Toolkit, you can use this little tool called ptmaxed, which will allow you to tabular format the data with you know, for 1 second interval, right, or some other, which in many cases can be very helpful way to see that information and analyze them by looking at how different variables change altogether. Moving on to information schema. Information schema has more than 60 tables. Some of them are schema related, show us information about the tables, indexes, and so on and so forth. Others contain information about various performance statistics, right? Schema info would be things like tables, right? As you can see here, while we also have the metrics information stored in it. The most helpful is Innodb Metrics, which is kind of similar to the show status, but provides some additional information. You know, besides the count, you can see it stores max count, when the counting was started, and so on and so forth, right? As well as provide us a little help what it's about. Now, the thing about the Innodb metrics is not all values out there are enabled by default. If you want to enable them, you can do Innodb monitor enable equals to all. In my experience, it has a very little additional overhead. So if you like getting more stats from your system when you use them, then that is a good variable to enable. The performance schema is really the instrumentation of choice in MySQL. If you look at all the innovation in instrumentation in MySQL in the last 5 years, 90% of that goes to performance schema. Now it contains more than 100 tables, and there is a lot of stuff you can do with performance schema, but only some of that things are enabled by default due to performance overhead. You can enable instrumentation permanently or temporary, right? If you, for example, troubleshooting some performance issue, but you need to be mindful of the overhead. Now, how do you configure that performance schema? And this is kind of complicated and powerful at the same time. The configuration is also stored in the MySQL and can be configured using SQL statements, as well as you can use myCNF, right, for static configuration. Setup actors tells us what users from what host will need to be instrumented. You can pick and choose, right? You, for example, can choose to only instrument the user for given batch job, right, or skip some users using this configuration. Then consumers are essentially shows how the data is being aggregated, and you can see by default some of them are enabled, some of them are disabled, but you can control that. What kind of summaries do you want MySQL to provide? Obviously, the more summaries are maintained, the more expensive it is, the more overhead is going to be. The next step is the instruments, and these are the instrumentation points, right, where MySQL 8 has now more than 1,000 instruments, and quite a few of them are enabled by default, and some are timed, right? You can see not all of them are timed, because timing is significantly more expensive compared to just counting number of values, right? But again, you can configure that in a way you want. The next is you can also choose to see what objects you want to instrument. And you can see by default, MySQL does not instrument, for example, MySQL schema, performance schema, information schema, but it does instruments everything else, right? I'm not sure I like this configuration, right? Because, well, I mean, I think we should really capture all the workload and kind of really filter that on the high level if you want to. But that is how default configuration comes in MySQL 8. And also we can specify what kind of threads we want to instrument and not for the background threads. So if you look at the example of performance schema data, this is how it looks, right? This is information about the given statement, right? And you can see there is a time in here, start and how long it took, right? And the values are very large. They're large because the unit performance schema uses is a picosecond, right? Which is a 1/1000th of a nanosecond, right? So very high resolution data, right? But that also makes it kind of a little bit hard to use. If you want to use performance schema directly rather than use some tools which capture that data, then you can use sysschema instead, which is now shipped with MySQL. And what sysschema is, it provides us views and stored procedures to access performance schema data, often in much more convenient way. So you can see it has views for humans. It also actually provides this kind of same views if X dollar added to them, which has a views for machines, which has the same looking data, but they do not simplify the units, right? We're not trying to show you seconds or minutes or kilobytes and megabytes, right? Because for machines, that's inconvenient. So as an example, you can see if you look at the sessions, right, which shows us the current kind of similar things what show Processlist shows, but with a lot more details. We can see all this kind of stuff, and you can see it has been simplified for user views, right? We can see what statement latency showed in microseconds, while the transaction latency in milliseconds, right? Instead of using units as picoseconds, that is much easier for humans to understand. If you, however, look at the same stuff from a machine's view, right, you can see it's kind of shows a very similar data, but in this case we are back to using the actual data for for various counters instead of having it simplifies, which is much more convenient to consume in scripts. Another cool stuff it has, for example, information by client hosts, right? In this case, it tells us, hey, this given host, how much activity it has. Sometimes the information can be slightly buggy in a performance schema, right? So I would always use approach of trust by verify approach to this. Like in this case, on this system, which has a couple of gigabytes of memory, it tells me what's total memory allocated on the client of this host is 2.7 terabytes, which is kind of confusing. Well, in reality, though, this is the number of the total allocations, right, of all the calls to allocate the data, what was executed on behalf of this cost, which is kind of, just confusing variable. We can also look at the file IO by hosts, which can be very helpful. And you can see in this case is what whole bunch of IO happens in the background in your case, like Innodb buffer pool flashing, checkpointing, the various insert buffer merging, and so on. So all examples of a background IO. We can also see the type of IO in this case by looking at what kind of type of file, being that data file, log file, and wherever IO goes into, which can be very helpful, right? You can, if you see a lot of disk IO and you want to understand where it comes from, this is their data you can look into. And also we can look at the different statements here as well, right? Like in this case, we are again looking at the summary for a given host, and we can see things like how many total statements the host run, what was the total sum of all the statements executed, what was the max latency, right? In this case, we see, well, one of the queries this host run was taken 51 seconds, right? And a bunch of other helpful statistics. And statement types per host is also, in my opinion, is quite helpful data, which allows us to really understand the type of workload. Is it select workload, update, select, and so on and so forth? In many cases, that is a very helpful to know that data. Now, I mentioned what we can look at the file IO by type, which talks us if that's a data file, log file, and so on and so forth. Now, with information schema, we can also really look at that by specific file. In this case, we can see what the Innodb data file, that actually can be a whole bunch of different data files, right? You can see table name .ibd, which allows us then to drill further to understand what kind of IO is being done. Another valuable thing in this case you can look at is also look at the IO latency by or by IO type. right? Like in this case, we can see both information about the total read and total written. So we can see what kind of files are getting reads and writes, right? Like for example, we can see from slow log file, that file is only written, right? There's a lot of gigabytes of writes, but no reads. In Innodb log file, there is a little bit of that what was read, probably during the start, right? But majority of that being written. Innodb data file has a lot of both reads and writes, right? So that can be very helpful to understand what IO pattern given files have. The next one, what performance schema provides, is the memory allocation, right? Where you can actually see how much of memory is currently allocated for different objects, right? Like typically we'll have a lot of memory allocated for buffer pool, but you can see also we have some objects for temporary table allocated. We have some table cache and so on and so forth, right? You may find some surprising data here in terms of what are being your top consumers of memory in your cases. And then we can also look at the Innodb metrics in a kind of over enhanced metrics, right, which combines the status from show status as well as Innodb metrics, which gives us a little bit more information, right, about where this variable come from. Like those come from global status, they're enabled, well, they're always enabled in this case, and so on and so forth. I mentioned what in the start, what performance schema provide, or schema provides a session variable, which talks about the current sessions or connected clients. You also have a process list table, which shows us the similar stats, but about all threads, including background threads. Like in this case, you can see as example, I am showing full text search optimize thread, right? That's one of the internal Innodb threads. And you can actually see what exactly that thread was doing. In this case, it's not much meaningful, but in others, like for replication threads, there may be some good meat here. It also provides, besides information schema, some other helpful things. Like for example, one of the relatively common causes of a downtime is run out of after increment space, right? You can check that if it's the tables, or you can look at redundant indexes to see if there are some indexes which you don't need and you may drop. You can also use that to look at the table access statistics, which is very helpful to understand what kind of hot tables you have and what kind of workload is hitting those tables, read, write, is it IO bound or is it CPU bound, as well as find the indexes which has not been currently used. Now be careful because in this case, for example, it's rightfully identified as foreign key indexes, as in indexes which are not used, but you can't really drop them and expect the foreign keys to work, right? So not all unused indexes can be dropped, mind that. If you are concerned about security, which you should be, then you can also check out this SSL status table, which tells us which clients are using SSL, which are not, and what kind of SSL configuration is used for that session. I already mentioned this. What another cool tool in the row tables, but another cool tool schema provides is you can also look at statements analysis table, which tells us the summary about the given patterns, right? For example, in this case, we can see what relatively harmless on the surface statement show global status actually responsible for creating a lot of temporary tables, because that is what it does for internal executions. You can also use this information to find the queries with errors and warnings, which can be very helpful in many cases, and can be helpful to store both like a schema design errors, like maybe trying to access columns which has been dropped and don't exist, or even catch SQL and injections. We can also look at the summary by users, as I previously showed by the host. And you can also go into the more global waiting for information, which actually sums together all kind of instruments, files, logs, latches if those are enabled, and so on and so forth, right? And shows how many calls for given wait, given object was done, and what is the total latency if timing is relabeled. One of the pretty cool features we have in this feature is also latency distribution, right? You can see here. Okay, moving on. We have a whole bunch of logs available in MySQL 8. One of them is slow query log, which we use a lot, which gets a lot of information about the slow query. In MySQL 14 Plus, there's actually extended slow query log available, which adds a whole bunch of additional counter variables, which can be very helpful. Explain is something which existed forever and was improved in MySQL 8. That is something you absolutely need to know if you're using MySQL actively. And there are a number of ways you can analyze explain right now, right? Like you can get a basic explain in a table format which exists for a very long time. If you want more information, you can use the JSON Explain, which gives a lot of information, but can be hard to read for humans. So in MySQL 8.16, we now got a tree format, which is kind of gives a lot more information than the table explain, but also can be often easier to read for humans than the JSON format. And then also what we got in MySQL 8.018 is explain analyze, which which doesn't just estimates execution plan, but actually executes the statement and shows us what the actual execution timing was versus estimates, which can be very, very helpful for analyzing performance. For some advanced stuff, you can also use optimizer trace, right? If you really don't understand what's going on and why this query executed this way, you can use this little tool to use the optimizer tracing. Now, in a few slides, I also wanted to talk about Percona Monitor and Management, because that is a tool which we use at Percona and develop at Percona to provide a lot of the MySQL 8 observability features for you in a simple way. Like you can find which queries are causing the load on the system with PMM. You can hopefully understand why they're causing the load. Like this query shows, hey, you know what, most of the time, it's spent as waiting on log, so you'll know how to troubleshoot that query. And also how to improve them, right? Where we provide you information about the query execution time, the query itself, explain, and the underlying tables on one page, so hopefully you can really fix them easily. We also provide a lot of details information about the system monitoring, because in many cases you cannot see, you cannot really think about the MySQL when you don't really understand what's going on underlying system in many cases, as well as MySQL summary highlights a whole bunch of information about the performance schema, where additional to the stuff which this schema provides you, which is, or performance schema, which is about what is happening now. We can see the trends over time, or a lot of very advanced stats we have about the Innodb internals, as again, we've trained in over times. And if you want to check it out more without installing that yourself, I will encourage you to check the PMM demo at percona.com. And with that, that's all I have for you today. And it looks like we have a couple of minutes for questions.
Wonderful, Peter. Thanks for giving us that. And let's start with the question that is on most people's minds, which is with additional observability, trying to dig into this data, isn't there more overhead for all of that, right? Aren't we going to see a lot more performance hit, and isn't our system going to suffer as we start to look deeper into these?
Oh, yes, of course there is, right? Now there are a couple of things to consider. The first one is if you look at the systems which fail and break down, it's almost never because they have enabled too much instrumentation. But that is because of a bad queries, bad configuration, and other bad decisions which are often taken because of lack of that information, right? So typically, if you're actually using the information you are gathering, you will get much better performance system by having it, right? Because of how well it allows you to optimize system and improve performance. The second thing is what you need to be smart, right? And it doesn't make sense to have all data capture enabled by default all the time, right? Certain data is certain information you only want to enable it capture when you are diagnosing the system, or some people would have what's called would be like canary system, right, which has all information enabled on that, and that's maybe only 1 out of 100 of MySQL nodes you have in your sharded system, right, which gives you more data, but the same performance data would naturally apply to other systems in your environment, right?